Students, we have completed the chapter thermal expansion of solids in our theory classes, and we have started doing the numericals, isn't it? So we have done some numericals from your coefficient of linear expansion. Okay, coefficient of linear expansion, some sums numericals were done, and now we have started doing some numericals from the coefficient of superficial expansion. Okay, I'm just writing the chapter's name. Thermal expansion. I'm just writing expansion in short. Okay, in your exam you will never write expansion as exp. Write the full word. Okay, so what was our first sum from your superficial expansion, students, or the coefficient of superficial expansion? I'm just discussing it in very short way. Okay, so I think that was your sum number 5. You can check it out also. Discussing sum number 5 in a very short way. So let's see what it was it. The base of an iron saucepan has a diameter of 0.20 meter at 15 degrees C. What will be the increase in the area of the base of the saucepan when it is filled with boiling water? Clear? Given coefficient of linear expansion of iron, the value is given. Okay, so what was the question is telling us? That you are having one saucepan, iron saucepan. It's having some diameter and it is kept at some temperature. Okay, what will be the increase in the area of the base? That means what change in the area of the base of the saucepan you can able to see when it will be filled with boiling water. What physics, students, is happening here, or what physics you can observe, since it has been filled with the boiling water, so it's very obvious that the saucepan will expand, isn't it? Suppose the saucepan was this, the base was like this, more or less, very rough way. After pouring the boiling water, it has been assumed that the base will increase. Okay, so you have to find out the area, the increase in the area of the base of the saucepan. Okay, so what we did in the first part, from the we were given the diameter. From the diameter we can find out the radius. I'm just discussing in a very short, I'm not doing the detailing part. Okay, what was our coefficient of superficial expansion's formula? It was S2 minus S1, which is equal to S1 into beta into T2 minus T1, isn't it? That formula we have used. Okay, yes, that beta is the coefficient of superficial expansion, and these are the change in the surface area. Okay, this is your the previous surface areas S1. Okay, so how are you going to find out the S1's value? S1's value, you can write it by the formula pi r square. Okay, you, you can see that in my previous video I have done the calculation. Now I'm not doing this. Okay, this pi r square calculation, I'm not doing it. Now it's time for the beta's calculation. Beta's calculation will be what? If you just check out, beta will be equals to 2 alpha. How I'm writing this? From the relation of the alpha and beta. In the class we did the derivation. Clear? And the change in temperature also you can able to write that value. Okay, you can able to calculate. Now what was the last part that we did not do in this sum? So after calculating all this value, T2 minus T1 also you are getting from the question itself, you can able to calculate. Beta's value 2 alpha, okay, because in the question the value of coefficient of linear expansion of iron is given. So you just multiply it by 2, you will get the beta's value. Clear? And the S1's value how will you get? By pi r square formula. Okay, so all the values you are getting. So finally the required increase in area I'm just writing the required increase in area is what? Pi, that means this S1 into this, that means I'm just following this formula, students. Have you noticed? I'm just following this formula. That means S1 into beta into T2 minus T1. Just following this formula. For S1, you can calculate it from this part. So it will be getting, okay, I'm just writing the, okay, the mathematical expression. You can just calculate it out. For S1, it will be pi r square. R means 0.10 square, okay, into beta means 12 into 10 to the power 6 was given. So this into 2, that means 24 into 10 to the power minus 6. Okay. And for this T2 minus T1 part, just do the subtraction, you will get 85. Clear? So 85 meters square. I'm just writing the 85 numerical value. Okay. Just calculate it. How much you are getting? Okay, I'm just writing meter square here also. You will get near about 6.406 into 10 to the power minus 5 m square. Clear? So just for this sum, we have followed this formula. Okay? Why? Because in the question, students, you will always read the question what has been asked in the question. Then you follow. Then you follow the formula. Which formula you have to use. In the question, it has been asked what will be the increase in the area of the base. Increase in area of the base means we can write this formula, isn't it? That is your S2 minus S1 equal to S1 into this. Okay, I'm just not repeating it. And just students, yes, if you just go to the theory sections, in the theory sections only you are having the formula for the beta. Okay, I've just followed that. I'm just writing, students, here. This is the maths part is done. Okay, just the theory. Okay, what was the formula for beta that you have calculated? S2 minus S1 by S1 whole divided by T2 minus T1. You just check it out.